Hello. So we are finally ready to write the actual input logic where the user types something and the keyboard appears on the screen showing what the user is allowed to type next. In other words, input codes consist of usually more than one character. Most of them do. And so the user presses one key, and then the keyboard on the screen shows all the codes that the user can continue to enter that start with that one key. And so what we'll do is we'll create an input subcommand in the new sort binary, and it will start up showing this. These are all the characters you can type that have just one code, and the user can press A, for example, to enter this character, or Shift A to enter this character. They could do Shift slash to enter this character, and so then the user in this input subcommand, the user can press X, and the keyboard will show this, which are all the codes that start with X that are only 2 characters long. And if the user presses A, then that means they wanted to enter this character. And so imagine the user presses A, then the keyboard's going to reset to the original one because now the user is going to type a new code. And so for this step, I don't think so. For the very first step, we're just going to implement this logic where the user types one key, and then this keyboard is shown. Not that one, but perhaps this one. The keyboard is shown, which indicates what the user can type next. And it's not actually going to show it in a pretty fashion. It's just going to dump it to the screen. It's not going to redraw it in place or anything like that for this first step. It's just going to show the keyboard so the user can actually see it, not so that it looks good. So the idea is that so that means this input command is not going to work all that well, but for testability's sake, it's going to be very easy to test because it just means we send one key to standard in, and then we expect something to be outputted as standard out, and we don't have to worry about control sequences or like the direction the ANSI control sequence, which tells you to reset the screen or move the cursor to a certain spot. We only have to test the keyboard output. And so then so it's going to be very easy to test, and when we want to actually run it in non-test mode, we'll just set certain flags so that it prints stuff out prettily. So let's just get started. I don't think this is going to be very difficult, but who knows. So we want to open the we're going to add a keyboard command. Oh, we input command rather. So yes, we have keyboard here. We need to add an input command. So shared objects. I think we just have to add something to shared objects here. So input.o. And input does not need a header file, although we do. We need an input command as well as an input like module for testing, so that we can reuse it. So how are we going to do that? Let's see. Well, we can just invoke the input command in the test, right? There's no real reason why we have to we have to do it a certain way. Although, I mean, that's how we did the last rank contain thing. So I don't think of a reason why we have to create two different things, like a testable module and then the actual user command module. So let's just try to do it. Yeah, I'm not sure how I want to do it. Let's just put it all in one spot for now. If I'm not sure, then I guess I'm going to do the lazy thing and just hope that works out. Later on, we can always fix it. And so we'll add a test as well, which is input test. I'm kind of adding this preemptively, but we know we're going to write that test. Now, input.h. well, let's see here. Commands. I want to make sure that commands.h has a redirectable input standard in stream, and it does not. So let's do this. We're going to have in, and let's go to commands.c. All right. Now let's make sure this is okay, because if we have any name conflicts, it may not work. Excuse me. Okay, there's no input.c file yet. So we're going to do input, the input command, and commands.h. So, oh, where's the keyboard command? I thought there was a keyboard command. New sort, keyboard. No, there's not, I guess. Okay. Input char. Let's do this. All right, so we have our input command, and have the definition of the command, and we're just going to return 0. Yeah, we're going to have to include commands.h eventually. Let's just include it now. Let's try it. No rule to make target input test. Okay, so I'll make input test.c, and this is, let's see, let me copy another test. Test util, and just we have an int main. All right, return 0. Okay, good. So edit input dot c. So we're gonna have a kind of indication of, let's see, we want to have a the input characters that the user's entered so far input, I guess, and this is gonna be for, let's see here, let me look at we have a type for the input codes, and that's here, orig. So we can change this. Let's make this into a type. Let's see, git grep. Let's see where we actually use this number. Okay, so we're kind of using this here a few times. So code edit keyboard.c 42 go full code. So maybe what we can do is we can go to romaji.h and make this a type def. So type def char b orig type. Okay, this is a null terminated input code. And then over here, full code. Okay. So let's make sure that works. Input so far to finite. Okay. So I do want to put this into like a separate commit. Static char, static. It is what's it called? Orig type. Okay. Let's comment it out for now. Okay. Now let's do a interactive add of omaji.h. And oh, we don't have to do it interactively. We can just add the entire file. omaji.h. omaji.h. And then we had something in keyboard too that did it. So add keyboard.h and no, keyboard.c rather. All right, now factor conversion type, factor input code type into type def. All right, good. Okay, so we have that, and that is for this very first step. That's really the only state that we need that I'm aware of. So let's go ahead and start writing this. But when do we want to stop? What's the termination condition? I guess the termination condition is the user enters some key that is like maybe the user types escape. Perhaps that's a good way to indicate the user is done. What is escape? Escape is like this thing, this like caret. What is the S? I think that is like \003 printf. Or was it 33? I think it's like also E, right? Man ASCII. Okay. 3 ETX. No, I guess that's not it. 33. It's O33 in octal, or \E, I believe, can also be used. Printf. One B. Yeah, that seems correct. B is 11, so that's 27. 16 plus 11 is 27, and in octal, I guess that's 33. Okay, so we can use \E to indicate that the user is finished. And all right, so while one and int ch equals xf get c. I think we have this character, right? In edit. It is in util.h. xf get s. You need xf get c. F get c. So I don't know if this is going to be changed to use the system calls, like the read system call, rather than this C standard library thing. But for now, I'm just going to stick with standard C calls until I'm forced to switch. Times xf get c rather. Xf get c returns an int, and it takes a file. Xf get. And I think that it outputs like a -1 for the end of the file or something like that. Return value. Return the character as an unsigned character or cast to an int or EOF or end of file, on end of file or error. Okay. So do we just want input to terminate on a negative, like end of file instead of escape? Maybe we want to do that just for simplicity's sake because we don't really need anything else yet. Xf get c. And so util.c xf get s and int xf get c file stream. So this is going to run fgetc and terminate if there's an error. So int c equals fgetc stream. If c equals EOF. But wait, is there a way to even determine if there, what is the difference between end of file and error? Does it set error no? Sorry. Let me just read this real quick. fgetc reads the character from stream, returns it as an unsigned char cast to an int or end of file on end of file or error. Getc is equivalent to fgetc except that it may be implemented as a macro which evaluates stream more than once. Getchar is equivalent to getc. Well, getc, huh? Getchar is equivalent to getc standard in. FgetS reads in at most one less than size characters from stream. Okay, we don't care about that. Unget C pushes C back to stream cast to unsigned char where it is available for subsequent read operations. Only one pushback is guaranteed. That's interesting. Calls to the function describer can be mixed with each other and with calls to other input functions from the standard I/O library for the same input stream. For non-locking counterpart, C unlock standard I/O. And so this does not explain how to detect an error. Let's do a quick search. Fget C detect error. Use like this. If the error indicator for the stream shall be set, fget C shall return EOF and shall set error node and indicate the error. If read error occurs, the error indicator for the stream shall be set, fget C shall return EOF CX. Okay, so if we return, we can check error node, but we need to make sure error node is, I guess, 0 at first. F error is not equal to, okay. Here. I guess we need this. So, if error stream not equal. Okay. So, what is F error? How does F error work? If EOF tests the end of file indicator for the stream pointed to by stream. File indicator return non-zero if it is set. F error tests the error indicator for stream. When stream return non-zero if it is set, the error indicator will be reset only by the clear error function. The function file node examines the argument stream and returns its integer file descriptor. And do not set the external variable error node. Should not fail and do not set the error node. However, file node detects that argument is not a valid stream, it must return -1 set error node e bad f. Okay. So what I'm confused about is how do I know what the actual error is? And it seems like there's no real way. F error. What does it return? It returns check and reset our stream status. Stream return non-zero if it is set. Yeah, it doesn't really say how this works. So okay. So if error is set first, then we say a bug file has unacknowledged. I'm going to rewrite this anyway. Unacknowledged error. Okay, and int C, and then here we can die. Fget C error. Okay, then we return C. Okay, now here, if CH is -1 or EOF rather, then we can break. We're done. Now, otherwise, we need to add it to so far input. Now let's see here. What happens when the user types in some characters that are not valid as like an input sequence? How are we going to handle that? So we need to be able to find. So first of all, we're not actually we forgot to actually generate the input map, right? So and this would be a good reason to actually not use the command exactly, because we need to be passed in and told what the input, like the input mapping, actually is. So Okay. Let's just do it like this for now. Actually, I'm happy with this. So we need to go to make map.h, I guess. No. Let's see, keyboard.h. I want to create the mapping, so it is key edit make map test make map ergonomic sort edit make map.c. Okay, mapping, and then mapping destroy down here. Okay, and mapping.ergonomic sort equals 1. Oh, that's funny. I don't need to set it explicitly here because okay. Anyway, I can't fix that now. It's already committed and pushed. So mapping.ergonomic sort equals 1 and struct yeah, okay. And we need to mapping populate 8 mapping. Okay. Okay, so now we have these input codes, and so now we're going to say, the size of previous size equals Sterling. So far input. Actually, it doesn't make sense to keep this as static out here in global. I don't think we need to do that. So far input. Okay. Equals 0. Initialize to 0. And so previous size. So if previous size is equal to size of so far input minus 1, well, this means that we're already too big. I think we can probably check this later. So if that happens, we're going to clear it. Memset so far input 0. So size of so far input. Okay. Now where do we output the keyboard? I guess we output it right here after the user has typed something. No, but we want to, I guess we got to do it here. So, xf get c. Do we want to make this into a function that also prints the keyboard? No. Let's just do ch equals that. And previous size is that. So we can set that here, but right here we need to do the keyboard first. So let's see. I think I already wrote code to do this. What tests do we have so far? Test, check kanji database order, input test, keyboard test. Is it in keyboard test? So draw keyboard. Right, we did. So keyboard update, edit keyboard. Actually, keyboard.h prefix. Oh, this can be the input code, right? Right here. Prefix can be the input code, but I guess it doesn't matter. So, because it's not a statically allocated thing, it's just a pointer that the caller allocates. So let's see, previous size. Now we're going to do keyboard update, I guess. Keyboard update mapping. And we need to set the so far input, right? And then we draw keyboard. The draw keyboard is a function in here. So yeah, we have f right here. Xf right. We don't have a util for xf right. Util.h xf right. No. Okay, so we can make it, we can do that now. Let's edit util.h. We can add an xfwrite thing. Void xfwrite. Now, do we need to return anything from xfwrite? Man fwrite. Return value. Return the number of items read or written. Transfer only when size is 1 if an error occurs. Oh, the reason why I didn't want to make this is, yeah, because I don't really know these helper functions that die in error. I don't really know how they should work if the input is if the what am I trying to say? If we write partially, that's not really an error. That's a half error, and I don't know if we should always die on in that case. So maybe we can do this. We can make something else, I suppose, like void xf write all. I'm not sure if I like where this is going, but so the idea is that we give it some bytes, void pointer, and I guess it's const, and the size, and then the stream. Right, f write all, xf write all. Yeah, but the thing is, we're only going to do this for the keyboard, right? So maybe we really should add this to keyboard.h. This is more less surprising. So we can actually do like void keyboard, right? And we send it to out, I suppose. We always want to send it to out, really. So we can just do keyboard write, edit keyboard.h, keyboard write. Well, I don't want to have to depend on that header file, the commands header file for this. So let's edit make map keyboard test, right? Edit keyboard.c, keyboard update, keyboard size, keyboard update, size, and write comes right after bytes. Let's make it after these here. Why am I not getting it? There we go. So keyboard write file stream. Okay. Keyboard write. And put this down here. Okay, so now we can do keyboard write out. Okay. All right, there must be a bunch of stuff not compiling at this point. Mapping equals that. Okay, here. Pound include mapping.h, is that what it was? Mapping, yeah, that's where I declared the mapping struct. And that for the orig_t type, make and file that needs standard IO. Wait, where's that used? Keyboard.h, not here. Okay. Let's try again. Sterling. Okay, we need that in input.c, string.h. And we also use size t. Maybe we should use standard def. Where's size t defined? Standard def, I guess. Include standard def.h. And sterling. What else? Error no. and arrow is defined in arrow.h. And this GNU source define is not needed right now because it's done in the make file. So let's do that. Let's get rid of that real quick. Interactive and util.c patch. Yes. And then no for the rest. I think I can just quit. All right, quit. So now GCM remove unneeded define, which happens in makefile now. Okay. Okay, so we're getting closer, but there was something else I wanted to commit separately. What was that? It was the keyboard update thing, I suppose. So keyboard.star. We need to add keyboard right, and in the keyboard test.c, keyboard and what do we want? We want out. Keyboard right. Okay. Add keyboard star. Okay. Okay. Oh, that didn't work. Keyboard update input.c. Oh, because okay. So we only want to fix the compilation errors in keyboard.c, I guess. Or here, let's input keyboard.h here to silence all the other crap. Pound include keyboard.h, even though we're not going to commit this very soon. xf get c. Input.c does not include util. So util. And then arrow keyboard.c. Okay. Edit keyboard.c. And util.h, I guess. Identifies only once, shield.c. Util.c does not implement die. Oh. F get c error util.c. We don't actually have a die function yet. Probably want to take care of that eventually. F print f or xf put s. And then exit some random number. $213. Okay. XAS printf. VAS printf. I don't have this. Oh, edit make file. I remove the define. C flags. Oh, I didn't actually move that define as I thought I did. So I did that in a different code base and for different projects. So actually GNU source here is what we want. Make. Okay. So we need to amend this one. So I will make file. Add p make. I'm going to just add that first change up there. Make file. Yes. Quit. So now we can do commit. Oh, but we didn't actually finish this thing here. So keyboard.c. You see keyboard star. So this is where we move stuff into a separate function. So here, keyboard dot, so keyboard star, GCM keyboard dot H, keyboard dot C, keyboard test. All right, and we say we move keyboard update, keyboard write logic to shared function. Okay. And then make file. So make file, we got to amend this. No, just don't specify what files, just do this. So we, this is a fix-up rather. GCM fix-up equals 2. Okay. Now, okay, we're getting closer. Input.c here. So we're getting a new character, and we need to see if we filled up the input code, then we want to reset it. Also, if we found a matching input code, we want to reset it because that means the user is kind of done. So how are we going to handle? How would you want to do that code? We're going to have to do binary search. So how did we handle that before? Keyboard.c. We did like a binary search here. Key mapping. Okay, so we got to look for a key mapping here. We can make an is done. Static int is done, and we give it a struct mapping m and a origt const so far input, right? Okay. So what we'll do is if Sterling of so far input is size of so far input -1, then we return 1. And we also do struct key mapping const m mapping. Here we do a binary search. Mapping dash codes.l mapping dash codes. I'm copying from over here the binary search stuff, and code comparison m dash original so far input, and then return m is not equal. Let's see, yeah, m config. Okay, that the two bangs just convert a non-boolean to a boolean. So let's see here. So if EOF or is done. Oh, but we have to actually add it to add it here. So previous size. Okay, so far input. We need to say Sterling so far input. Oh. Okay, so it's already null terminated. We'll assume that so far input already has zeros filled in everywhere. So we'll do this ch if ch equals EOF, then we break. Otherwise, we assign it, and then so far input. Okay, and then we do the search. So if is done mapping and so far input, then we do this. Okay. Now the problem though with this is that I believe this is going to be line buffered. Let's see what happens though. Use variable previous size. Okay. Okay. So let's see here. We're going to add main.c. We're going to add a new command. New source input. New sort input here. And we add it. So we're not matching the order. Let's do if argc is going to equal to and argv input. Then return input argv plus 2, argc minus 2. Okay. Now, new sort input. Segmentation fault. Okay. So, why did that happen? Keyboard update, keyboard write. So we could probably do this. C flags equals CC flag. Oh, we don't want to override these existing C flags. So we add like extra flags, I guess. Oops. Repeat. Trying to repeat the command. Okay. Extra flags. So extra flags equals -g. Okay, now we can do a GDB on new sort. Oops. And run. Or set args input, I think. Set args input. Run. ferr.c, no such file or directory. Oh, we didn't initialize it. Commands.c. Where do we initialize out in error? Oh, we do it down. We should do it here. In equals standard in. That's all. Okay, yes. Make. Good. But if we do, you see it is line buffered here. So it's not quite what we want. It's getting there, but it is testable. And so I think that in order to handle this, we need to like set the input stream to raw. Oops, didn't mean to do that. Which I will have to figure out. But maybe we can at least test it. I mean, we can still write the test really. So we do like we're gonna do a line like a data driven test. So we do a static struct here, char const name, and then the input, I guess, char const input or standard. Yeah, input is fine, or standard in. But it's not called standard in really. Let's do in, and yeah, and then the answer will be in a separate file. Test cases equals. Okay. So this will be like K, I guess. K. So first key K, and then it is K for the input, right? Then here. We need to nest it like that. Okay, first key K. So we do a for size t test I for test I equals 0, test I is less than size of test cases divided by size of test cases. And that will get us looping through every single test, test I plus plus. Okay, so start test file, test cases test I dot name. And then we do end test expected content in file, right? And so here we need to mock out the input. So we're going to have to do like f open or something like that. So we need to, I don't know if we want to use a separate file. There's like an fmem open, but I think this is not portable. Like I don't think this exists in Mac OS. So I don't know if I want to use this. fmem open Mac OS. Yeah, it needs you need extra code to actually have it work. And let's see if, so what can we do? We can create a temporary file with this, using this stuff, I guess. We can make a temporary file with the input that we need. Edit test util.c. So I wonder how we are going to handle that. Do we want to, because we already use, we are in test, we already write arbitrary strings to a separate file, and or to a temporary file rather. So maybe we can just reuse that. So end test expected like this here. Let's see, expected fn mcast temp and dprintf. So where we actually, why do we use dprintf? Because we had a file descriptor. Okay. Okay, so I guess we're gonna make test util have a we're gonna put that in a separate function because we're gonna need that. So we're gonna have test util.h, and we'll do, let's see, expected. Okay. Contents, verify contents. So we're gonna do something like, all right, we don't need to return the file descriptor, but we do need to return the file name. So what we can do is we can say void store in file, right? And we do char const string or bytes. I guess we do just want this to be a null terminated string, and so then we do char template here. Template temp file template. Okay. Then we'll have end test store in file. Okay. Let's put this at the bottom. I'm going to copy this because we'll need it, and we'll say store in file. Okay. Yank to. Okay. There we go. Const stir temp file template. Okay. Temp file template. Okay. Then here. End test common. We don't need to call that, obviously. And so then we do this. If fd is -1, then we can say mcast step failed, and dprintf, that's the same, and close, and then yes, we don't need this stuff. Okay, good. Store in file. Maybe we can call it make temp file, or store in temp file, or store in file. Store in temp file. Okay, that's better. Now we go back to end test. So store in temp file expected. Right. Expected fn. Okay, then we end the test and we verify contents. I'm not sure how much white space we need. Feel like we don't really need it anymore. Store in temp file and test common. End test common. What does end test common actually do? It clears out error and test names, test source file. Okay. So let's make in equals, you need expected 26. Okay. So dprintf, man d put s, I think is what we really want, right? Man d printf. Yeah, we don't really need this kind of weird dprintf. We just need to write, right? We just need a write call. Man write, man write. Do we have an xf write? Oh, we don't have an xf write because we're trying to avoid making that right to a file descriptor. Count bytes from. Okay. So we do return value on success on error -1 is returned. On success, number of bytes is written is returned. 0 indicates nothing was written. It's not an error if the number is smaller than the number of bytes requested. This may happen, for example, because this device was filled. Okay. Okay, so we have to do write size t stir size. Okay. Then we do if write to file descriptor, the buffer stir size is not equal to size t written. Written equals that. If written is negative, let's see, number of bytes written. On error -1 is returned. If written is -1, then we know error no will be set. So xf printf error write for temp file failed. Okay. And then exit. Need another random number. 19. Okay. Write it. Okay, so we don't want this one anymore. Oh, we can just reuse the last one. Use this. dprintf. Close. Write for, let's actually tell what the temporary file is. Temp file template. Okay. Okay, try again. In equals 22 test. In, I didn't finish writing this. Do store. Let's just not do that right now. Okay, test first key, open. Input test first key K. Okay, this test failed, but that's fine. We kind of expect that. So I think we just want to commit the changes to test util. Store in temp file. Have some trailing white space here. Okay, and then okay, this is good. So test util dot cnh and put temp file creation logic in shared function. Okay. Now we can actually take care of this. So char input file equals slash temp slash input test in. You need 6 X's or something like that. How does that work? Looks like I have 7, no, 6 X's. Okay. Expected, and then store in temp file, start test, store in temp file. So test cases test I dot in. Then we start the test. Let's start the test before we write to the file. Store in temp file, input file. So then we got to do xf open of input file for reading, and in equals that. And then we, let's see, and test common. Oh, but should this input thing be in the test util logic? Maybe it, well, for now, no, let's not do that. So we'll just set the standard in here, because I think very few commands are going to have standard in. Maybe only this one is going to use standard in. And so then we do xf close in, and then actually test util.h xf close, and then in equals standard in, and test. Okay, then we do we actually run the command. So input takes argv first, so we'll do then argc, just do that. Input, then store in temp. Okay, I think this is ready. xf close. Okay, we need to import util. We didn't write this string properly. We need to fix that. And then void value not ignored as it ought to be. Start test. Okay, that's fine now. So make and chart input file. Okay. Then we have to get commands.h. And here, no such file or directory. Okay, test out. So okay. Let's see what the test created. Okay, good. That's kind of what we wanted. But input is not making a new line after the keyboard, so we need to add that. Let's see, keyboard right, and then we'll do xf put c out. So the reason why we don't just do it in keyboard right, well, we could do it in keyboard right, or we can also do it in keyboard, we could also put the \n here. I don't want to put it here because that means that when we're drawing on the screen using a kind of like ANSI escape sequences and such, if we do then we're going to create an extra line at the bottom, and it's going to do extra scrolling, and we don't want that. So it's when we do this \n, right? Even we're going to have an empty line at the end, and that's going to cause it to cause stuff on the top of the screen to scroll off. So we don't want to put it here. Now we could maybe put it in F right or keyboard right, but I'm not totally sure that's the right thing to do. So I'm just gonna put it here for now. Maybe it should be in keyboard right because keyboard right is taking the C library output stream, which is buffered and probably not what we're going to write to when we're really writing on the screen for real. But in any case, let's just put it here for flexibility's sake. And yes, so now we're going to do this. Now the test passed. Okay. So let's look at what the test output was. So good. It basically did what we wanted. K. So when we press K, that means the rest that we can type is this stuff, and that is what we want to. That is how we want it to work. So first we show this, this keyboard when the user's not typed anything, and then K. After they type K, then we show them this. So we did not actually. The problem here, though, is that we did not actually change standard in to use raw input. But the thing is, I feel like this may be a good time to end the video anyway. Okay, make file. So I'm not really sure how to handle this extra. Let's call it extra C flags, and I'll add this. Let's add this line to the make file. Cgd make file. So okay, extra C flags. I wonder how the Git source code does it. I often check the Git source code to see how they did stuff, because I'm kind of copying a lot of their style and as it is. So C flags, how do they handle C flags? Compat C flags, guard against found variables, compat C flags, compat objects, set C flags. These might be tweet by config as well as command line, both of which will override these defaults. Basic C flags, pthread C flags. All C flags. Did they use GNU source? Maybe not. No. Because basically the GNU source has to be defined for the code to actually be correct. So maybe we don't actually want that that thing to be there. But I do want it to be kind of universal. So what function do we need for that GNU source thingy? Why are we actually using GNU source in the first place? Let's build it, and I think it was xaf printf or something like that. Make file. Let's delete this for momentarily. Oh, it actually worked. We don't need GNU source. Git grep GNU source. Okay. So why did I actually add the GNU source stuff in the first place? Let's do git annotate. I'm going to try and figure out when I added that GNU source thing. And it was, I needed to find this here. So if I go to h-5 and look in source/util.c, util.h, h5. Okay, GNU source. Do I do it here or I do it in the C file? Okay, this was added in 92E45, so I'll do 92E45. xaf printf. Was it for AS printf? VAS printf. Man AS printf. See feature test macros. So it's needed for AS printf. GNU source. They are also available under BSD. The freebie needs says term pointer to null on error. Okay. But still, I don't think we need GNU source. So apparently we don't need GNU source at all. Interesting. So let's just do this. Let's so gdc make file. Okay. So I think what I'll do is I will do another fix up of this commit. So I need to, no, I don't want to do that. Um, GDC makefile. See what is. Yeah, I want to cleanly remove this this junk that I added for the makefile. So what I'll do, I guess, is I will gd make. So I want to git reset makefile, get it back to where it was, just unstage it. Okay, so I'll do add makefile and yes, and then quit, and then I will do another fix up. But we want to reset everything. Git help reset. How do I reset everything? Git reset. Git reset star. I guess I don't really like the way this is going. Git reset star. And yeah, okay. So I'll do add makefile. Yes, and quit. And now I'll fix up this thing, h4. And next, so now next we're going to actually commit the real core of the work we did. So we created a new command which shows the keyboard as the user types in keys, and shows what the user can type after they've typed it, after they've typed the first key or so. And this required us to add a new kind of testability testability shim, which is a standard, which is like an alias for standard in. And so that is here. And we did the same thing for standard out and standard error, but because this is the first command that actually uses standard in, we have to add it there as well. And so this is a very simple command at its core once we've kind of moved all of the utility code into the right spot so we can use it. This just creates a mapping, a input mapping, and then it shows the keyboard with the characters users typed so far, and then it gets another key, and then it adds that key to the input string, and if the user is already finished typing, then they do memset here, so that the user can start typing something else. So actually, let's open input test. Let's make this a little bit this test more thorough because we did not test this logic here. So let's go ahead and input test. Let's see if it's handled where the user types in a complete command. First key A. So let's say the user types in KJ. Okay. So now we can do a diff of these two. See binary files. Okay. Okay. Delete 2E. Cat. Okay. So yes, it resets the keyboard as we hoped. So that means that this logic is okay. But does this logic actually work where we look if the users type something and it was not a correct code? I'm not totally sure what will happen there. Let's say the user types incorrect code. Incorrect code. This will be something like K capital K or K capital J. Just put this on the same line. In fact, we can put all this on the same line. Make. Okay. Now. So what do we get? Cat expected out test out and input test first key K. Didn't do incorrect code though. Incorrect code here. Oh, it shows an empty keyboard. So this incorrect key is not incorrect because we typed too much. It's incorrect because we just kind of typed a sequence which doesn't have a corresponding prefix, and so we need to handle that somehow. So let's think about the binary search thing. Keyboard update. Let's see. What do we do in keyboard? Edit keyboard.c. Keyboard update prefix. So we are essentially looking code compare. Okay. Mem copy. Okay. Mappable char count. Oh, I see. Because we're basically looking for, we're trying to see if there's anything that that the user is able to have entered. Okay, so the idea is that we add a potential key after mappable char count and see if there's anything that matches when we add a new key to the input code. And so if nothing matches, that means that we kind of have a problem. So I think that bsearch is going to have to be changed to find when something is like partially matching, or when there's there's a place you could have put something in the keyboard, but it doesn't work. In other words, so we have this new sort task. Let's see. So so we have keys. So this is what kind of is happening here. So we have like input codes. We had like K, J, and K, K, and K. What comes before J? I. I. Okay. So this is a code, and this is a valid code, and we also have oh, but there's KJ comes all the way down here, right? That's kind of because we sort it in that manner. So this is not a valid code, and so what happens is this we're going to do a search. What we're going to want to do is we're going to want to do a search for KJ, and basically somehow decide that there is no no code that even starts with these two letters. So what that's going to look like is it's going to look like, okay, we look for KJ, and the closest matching thing was K, either KK or KI. So if we look for KJ and the closest matching thing was either did not even start with KJ, then in that case that means that we can give up and the user has entered in invalid code. But then again, we also sort by length as well. So we're going to have to, like, we don't search for K capital J, we're going to have to search for K capital J backslash \1 to overcome the fact that we're sorting by length first. So this will actually look into things that are that long. And so if we look for that code and the closest matches we find are KIA and KKA, like that, then that means that there is no code that starts with K capital J, and so that means we can give up. But that is going to require some updating of the bsearch macro, which is a little too involved for now because it's going to require updating a lot of code. So what I'll do is I will just kind of save this test case, right? And we'll put it let me put it in my home folder, keyboard. Let's see, input test case or new sort task. We'll put it here. Put it in part 18. add input test case. Oops. All right. Now let's run this at this point. So here, now we're ready to commit, and so we'll say I'm just going to write a placeholder commit message, and this is like start writing input command. We don't set standard in to raw input mode, which would work better. And the thing is, once we set it to raw input mode, that means I can actually experiment with this more and kind of get a better feel for how the input is going to feel. Because that means I don't have to press enter after every single character. So this is probably a good point to stop the video, so thank you for watching.